Alright, hey guys, welcome back to my YouTube channel. This is the video about policy as a code, especially using open policy agents. This is the second video in the authorization series. In the previous video, I have shared with you about authorization models. The next questions will be how we can implement those models, what technologies we can choose to implement that. Disclaimer, this video is not a video about tutorial about OPA, right? So I just want to share the concept with you. So the table of content, we will see about policy as code with OPA, RBAC with Rego. So we are going to check how we can implement RBAC authorizations model using Rego language, and about just a little bit about Open Policy Administrations layer, or OPAL. Alright, let's start with policy as a code with OPA. When we started to implement authorizations, one way to implement it is hard-coded the authorization inside the systems that we have. It's easy to get started, right? Just do some logic here and do some logic there, right? It doesn't require a separate systems. It does make sense to implement in that way in the first place. But after some times, when the complexity of the system and the company and organization grow, for example, from monolith to microservices, the number of APIs increase a lot, number of users increase a lot, and then number of components inside the technology stack that we use also increase a lot. If we're still using hard-coded authorizations, there are some challenges that we may face. One is challenges in administrations and governance area, because we put the logic of authorizations here and there. So when we want to audit the authorizations, it might be challenging. And about consistency and access controls, because we may implement it in different way because we put it in separated places. So we may have a issue in consistency of authorization implementations. And also, for example, if you want to change or add new policy, and then we hard code the policy inside the systems, we might need to redeploy the systems, right, to take the effect of the new policy. So it slows to take the effect. One of the possible way to answer that challenges is using a concept of policy as a code. In this concept, we need a fine-grained way to build the policy using code. So it means that we can write the policy, define the policy using code, either using a general purpose programming language or using a domain specific language for writing policy. And then we need a standard framework for implementing, for evaluating the policy, right? Why we need a standard framework? Because a standard framework that already becomes a standard, probably hopefully will have less bugs, less issue, right? It's already mature, it's already stable, okay? And then if we do that, then we can have fully decoupled, fully separations of concerns of the policy authorization evaluations with the rest of the applications code. And one choice that we have right now is Open Policy Agents, or we call it OPA. It's already become a standard. It's part of Cloud Native Computing Foundations. Okay, so let's see how OPA actually works. Now we have OPA right here, so we can run OPA systems as standalone programs, or we can embed it in our systems. Let's say we create a separated systems. So we provide OPA with the policy, right? We write it in the code using a language called Rego, right? We write it in the code, and then OPA will read the policy that we read in Rego. And then if it's required, we can also provide OPA external data that we can provide in JSON format, so that OPA can evaluate the policy request accordingly. And let's say there is a request coming into the service, and the service needs to know whether this request should be allowed or not. Then the service can send the policy query to OPA systems, and it can be any JSON value, and OPA will evaluate the request based on the policy that we have put before, and then with the data that it already knows, and then it can return the policy decisions, and the policy decision also can be any JSON value. So OPA is a general purpose authorizations engine, right? The input and output can be any JSON value. So OPA here acts as a PDP, or policy decision point. It can give the policy decisions, but the service will be the enforcer. The service here will be the policy enforcer point, or PEP, that enforce the policy decisions. The service here, it can be anything, right? We can use it with Terraform, let's say, to prevent some deletions on the resource that we have on the cloud, to protect the configurations on the cloud system that we have. We can put it in Envoy, we can put it in Kubernetes, let's say, to manage the policy of ingress and egress. We can put it in Spinnaker to make a policy about who and when. We can run the job in Spinnaker. In Linux, we can protect some sudo uses in Linux operating systems, in GraphQL, in Elasticsearch, using Python or Go and any other language. So the ecosystems of OPA is actually big. So please feel free to check their official documentations to explore more about OPA. Okay, in the next session we will see an example of implementations of RBAC authorizations model using Rego language, in order you can get the feeling, right, how domain specific language for policy it looks like, right? Okay, so here is the example. I'm using Rego Playground. It's a playground that you can use to play around with the language and evaluate and see the result, okay, without needed to install the OPA itself in your computers. Right, on the right side there are 4 sections, 1, 2, 3, 4. One is where you can put the query, the input. Second is the data that you can provide to the language. Output is the evaluation output, and lint session is where you can see if there is any linter violations. Alright, so here we have a user assignments, right? We assign the user with roles, right? One user can have more than one roles, and one roles can be assigned to more than one user. This is level 1 of RBAC implementations, right? The flat RBAC. And role permissions is actually the role assignment. One role can have more than one permissions, and one permissions can be assigned to more than one role, right? So for this example, I put this data right here in the policy, but in real world example, you should put it here as a data where you fetch these permissions and user informations on another systems. You pull it, give it to the OPA systems in order OPA can evaluate the permissions. So here's the main logic, right? We want to decide whether this user should be allowed to do this action to this resource, right? So basically we check the roles that this user have. For each role we check the permissions, and for each permissions we want to ensure that there is a permissions that this user has the same as the input, right? If there is, then the low value here will be true, right? So in this example, let's say if we switch to Alice has engineering and DBA roles. So engineering roles can read resource server 123. So this, if we evaluate, should return true, right? Okay, nice. So if we change to Bob only has QA roles. So QA roles doesn't have permissions to write to server 123. Evaluate again, right? And the result will be false. Okay. And in the final blocks, I also has an example of SOD implementations, separations of duties policy, right? If you remember, I have discussed about SOD in the previous video. So in this SOD policy, I said that one user should not have engineering and QA role at the same times, right? If they do, then we will deny the permissions. So John have QA and engineering roles. John, right? So engineering roles actually can write to server 123, but because John also has QA roles, then the evaluation here will be false, right? Why it false? Because there is a SOD violations with this user John. All right, so this is Rego language. Okay, next we are going to discuss a little bit about Open Policy Administration Layer, or OPAL, right? So OPA provides several ways to get external data for policy evaluations. How we can send the data to OPA? There are several ways, right? Which you can see on these documentations. And OPAL is actually created by another company outside OPA, right? And OPAL is the administration's layer of OPA or any other, not any, or some other policy engines like Cedar from AWS. So how OPAL works? So OPAL components are server and clients, right? It consists of server and clients. So the server's responsibility is to ensure that the clients will have the latest policy that we put in repository. Yeah. If there is a changes in the repository, OPA server can acknowledge that by using a webhook or by active pulling from the repository, and then it will tell via PubSub to the clients, so that clients will know what is the latest policy code. On the other hand, there is a mechanism that OPA client can fetch some data resources from API or from database or from any other external services. So now OPA client already knows the latest policy and the latest data, so it can give that information to the open policy agents. Right, here's we install OPAL as a sidecar of OPAL. So when there is an application that send the query, OPAL agents can evaluate that based on the latest policy and the latest data from our systems. Okay, so this is the the last slide of this video. I hope you can enjoy it. In the next video, we are going to check about relationship-based authorization systems. Until the next video, keep learning and stay healthy. Bye-bye.